Welcome to 5.6, the remainder and factor theorems. We're going to do two things today. We're going to evaluate functions using synthetic division, and then we're going to determine whether a binomial is a factor of a polynomial by using synthetic division. So two things to do today using the remainder and the factor theorems. All right, let's get right into it. So here's the deal. We've learned how to divide using synthetic and long division. Okay, so now we're going to do something with that. Okay, so for this one, you can either use synthetic or you can use long division. I'm going to use synthetic division just to make a point about what's going on here with the remainder theorem. Okay, so what makes this go to 0 would be 3, right? So 3 would be the number I'd put in the box there, and then I'd have a -3, a 5, and a 4. We don't need any placeholders because we have all the degrees there. Okay, so let's just go ahead and try this. We bring this one down, we get -9. 5 plus -9 is -4. -4 times 3 is -12. And when we add those together, we get -8. Okay, so the remainder here, if I were to write this out, we would have something like this, -3x minus 4, and then we'd have a remainder of -8 over x minus 3. Okay. The remainder is what I want to focus on, the -8 piece. Okay, let's compare that to now plugging a 3, which is what makes that whole thing go to 0 again, right? It's what's in this box. Let's plug it, let's just evaluate the function at 3 and see what happens. Okay, so I want you to see the connection here. So I'll do this one in blue. If I did -3 times 3 squared plus 5 times 3 plus 4, 3 squared is 9, 9 times -3 is -27, plus 15 plus 4. If I add these up here, I get -27 plus 19, which is equal to -8. Okay, notice that the remainder, when I synthetically divide or when I long divide, whatever I get as a remainder, is also the same answer that I get when I evaluate the function at that same piece, right? Plug a 3 in. The reason for this is we're trying to test to see if this is a 0. Okay, so this will become a little more clear when you get into the factor theorem here shortly. But for the first part of the lesson, what they want us to do is they want us to evaluate a function at a given place. That means plug a 3 in to the f function, which is this function. And then they might, on the test, I think I have you do it both ways to compare to make sure. Okay, so evaluate using synthetic division and then plug a 3 into the function. So the remainder theorem says this: if a polynomial is divided by x minus r, then the remainder, which is what we just looked at, is a constant p of r, and the quotient times the divisor plus the remainder is equal to the dividend, just like regular long division. Okay, so all this is essentially saying is what we like to use the remainder theorem check for is whether or not something is a 0. Okay, so if something is a 0, which is coming in with the factor theorem, then I know that when I divide it out, I will actually get 0 as the remainder. Okay, so we'll get to that. Don't worry if you don't understand that quite yet, but let's do a little bit of this. So synthetic versus direct substitution, they're just showing you like you could find f of 4 of this function either by using synthetic division and making 4 what we're testing, right, and then dividing it all out. Or you could just plug a 4 in, which is what they do here, to the function for x, and you'll get the same result, the same remainder, okay? That's all this whole slide is saying. So let's do some examples. Example 1 says let's find f of 3. So you kind of have a choice here. You could either set up synthetic division and do it that way, or you could just plug a 3 in. I like to just plug the 3 in. You could do it whichever way you want. You'll get the same result. Okay, so you would do that kind of thing, and then for 1b, you'd plug a -1 and make sure you use parentheses there. So 4 times -1 to the 5th power plus 2 times -1 to the 3rd plus -1 squared minus 1. Just a reminder, on this one here, we have gaps. Okay, so if you're going to use synthetic division, you need a 0x to the 4th, and then you need a 0x term that you would put in there. All right, you don't have to worry about that if you're just evaluating it at -1. So when you do these out, you guys do some quick math here, you would get 19 for this one. And for this one, you should be getting -6. Okay, so you can test those out and make sure that that's making sense to you. And again, synthetic division you can use to just confirm that it's the same answer. This will always be the remainder. These will be the remainders when you're doing synthetic division. Example 2 is a word problem. I don't think I'm going to get into it, but they might give you a word problem like this on your homework, but to save time, I'm not going to get into it. Here's one thing to remember, though. If we're talking about years since something, just make sure you don't plug in the full 2015. In this particular case, X is representing years since 2000, so we would plug a 15 in for the X in each piece. Okay, so you could do that to find the answer to this one. And then the factor theorem. This is the most important thing of the day, probably. If the remainder is 0 when you're using any kind of division and you get a remainder of 0, then you know the original thing that you plugged in, the original thing that you were testing, is a factor of that thing. Okay, so the factor theorem says, again, that if, for instance, if you divided this guy, which we should do, let's just do it really quick, by x plus 3, and you get a 0 as a remainder, then we know that x plus 3 is a factor. Okay, that's if you get 0 for the remainder. All right, so if I do that, and then what they want us to do with that is, actually I'll save it for the example, but what they want us to do with that then is, if it is a 0, then they want us to find the remaining factors. All right, so once I take that out, we'll have a new quadratic. We can find the factors of the quadratic by just factoring as we've always done. So let's do one. It says, for example 3, show that x minus 2 is a factor of this guy, then find the remaining factors of the polynomial. A couple of ways I could show that. I could plug a 2 in here and see if I get 0, or I could just use division, right? So what makes this go to 0 is 2. 2 goes into 1, -7, 4, 1, so I can do the synthetic division, right? And then I would get, let's see what I get here, -6. Ooh, did I do this wrong? Hold on. 1 times 2 is 2. If I add 2 to -7, I get -5. -5 times 2 is -10. 4 plus -10 is -6. I'm not getting that this is a 0 here. 1 plus -12 is -11. So for example 3, it says show that x minus 2 is a factor, then find the remaining factors. Oh, I see what the problem is. Sorry guys. I believe this was supposed to be a 12, so this is a typo. If it's a typo in your notes, make sure you fix that. I was wondering, I was like, seems like I should be getting a 0 to test this. So the answer then is a remainder of 0. So therefore, this is a factor. So x minus 2 is a factor. Okay, then I'm left with 1x squared minus 5x minus 6. All right, so can I factor this? Well, yeah, I can. Two things that multiply to give me -6, add to give me -5 would be -6 and 1. So x minus 6, x plus 1. Let's make sure that that's correct. So if you FOILed it out there, you could test it to make sure that you get the same result. And in fact, you do. So the remaining factors are these guys. Okay, so all the factors for this would be x minus 2, x minus 6, x plus 1. Okay, so this really is the last factoring technique, you guys. I can now break apart things like this, right? I can test various, and in calculus, we'll do a little bit of this in pre-calculus if you end up taking that. We test various possible solutions. Then we synthetically divide, see if we get a 0. If we do, then we know that that was a factor. Okay, then once we take that factor out, we're left with a new polynomial, which we can factor down further. Okay, so we'll do a lot more of that in pre-calculus, but for now, I just want you to be aware that that exists and get a little bit of practice with it. Okay, so that's all we're doing. The homework, I'll have homework sheets for you, and we'll catch you guys next time.